This is Senior Algebra Section 3.3, Slopes of a Line. So today we're looking at slopes given a couple points, looking at graphs as well. So if I look at the first one here, we have to think about what slope is. Now you've seen slope before. So just a reminder here, slope, when we talk about slope, it's the change in y over the change in x, the change over time if we're looking at a certain problem here. But what happens when x's change and y's change here? Sometimes you'll see it in science as delta y over delta x. Those are the little triangles. If I look at A, the first thing I want to look at is the slope positive or negative? So if I look going left to right, the slope is going down. The line is going down here. So I would say that A is going to have a negative slope. If I look at B, if I go left to right, just like I read, the slope is increasing, so it's going to be positive. So if I look at A here, I'm going to start at a point, and I'm going to go down. The change in y, so it's down 2, so that'd be a negative 2. And then the x is going over 4, so to the right 4. We simplified a negative 1/2. Now notice, I could as well started at negative 4, 0 there at that point and gone down 1 over 2 to the right and still been on that line and still got the negative 1/2 here. I could have also started at another point and gone up 2. So if I look at the red point there, I went up 2, that's a positive 2, and to the left. Now when I go to the left, that's a negative. The x's are decreasing, so that would be up 2 to the left 4, or a negative 4. Notice the slope is still negative 1/2 here. Still going to be the same. So it doesn't matter which point you start at, which point you end at, the slope will always be the same. If I look at B, now B I should get a positive slope, so I'm going to start at a point there. And I'm going to go up and over. Rise over run is one thing that you've probably heard before. The change in y over the change in x. So I went up 2 over 3. I could go down 2 and to the left 3, negative and negative, and that would be a positive 2 as well. Sorry for the announcement here. So algebraically, how do we find it? Okay, we just looked graphically, I can count points, but algebraically I want to find it as well. So if I look at A here, I'm going to pick my points here. So I'm going to label my points here. The first point, negative 4, 0. And the next point, 0, 2. 0, negative 2. I'm going to use those to find my slope. Now, you've seen subscript notation here, y2 minus y1. All that means is y2, the point that is associated with the y coordinate for point 2. For the x's, the same thing. x1 would be the x coordinate for point 1. So I'm going to label it x1, y1, x2, y2. In this one, it doesn't matter. You could switch them up as well. So I'm going to plug in my points. So y2 is negative 2 minus y1, which is 0. So I have negative 2 minus 0. For the x's, I'm going to have 0 minus, and this can be a little tricky, so I do want to put it in parentheses, minus a negative 4. On the top, I get negative 2. On the bottom, I get 4, because minus a negative is plus. So I get negative 2 over 4, which is negative 1/2. Again, we get a negative slope, not a surprise looking at the graph. If I switched them up, if I said, oh, what if I wanted the first one to be x2, y2, and then x1 and y1? Well, what would happen? I would get 0 minus negative 2 and negative 4 on the bottom, still a negative 1/2. Slope would still be a negative 1/2, down 1 over 2 or up 1 to the left 2. So either way would work, doesn't matter here. In B, now B I would expect to get a positive slope. So the point 1, 3 and the point 4, 5. So I have x1 and y1, x2 and y2, and I'm going to go ahead and put the slope in. So I put the points in, 5 minus 3, 4 minus 1. I get 2 over 3, 2/3. Now notice when I go back, So I got negative 1/2 and I got 2/3 of my slopes. If I go back, that's the same thing I got when I looked at it graphically, when I counted. In example 2, we're graphing the equations, finding the slope here. Now we have 3 very distinct equations here. First one, y equals 5. That one's a little tricky. That's a horizontal line. So what's the slope? Well, if I started at a point and went to another point, how much did I go up? Okay, I went up 0. I went over 1. So what is 0 divided by 1? It is 0. So we say for a horizontal line, and every horizontal line, the slope is 0. If I look at the next one, x equals negative 2. I'm going to do it the same thing. Now it's a vertical line at negative 2. Now what's the slope? If I start at a point and I go up 1 over 0. Now, in math, there are certain things we can't do. One of them is dividing by 0. When we divide by 0, we can't, so we say the slope is undefined here. So for a vertical line, it has a slope that is undefined, or it has, we would say, an undefined slope. For C, I'm going to pick 2 points.
Maybe turn that back on.
So I picked 0, 6, 4, 3. And I plugged in 0, got 6, plugged in 4, and got 3. So I plot those points. 0, 6, that's my y-intercept, and 4, 3 is there. So I'm going to find the slope. Okay, I counted down 3, and to the right, which is the positive direction, 4. So it's negative 3/4. I could have done it algebraically as well. 6 minus 3, and 4, and 0 minus 4. Notice negative 3/4, it's also in the equation. That's in that form, y equals a plus bx, or mx plus b, however you look at it. We'll look at that in the next section. So the last thing, slopes of parallel and perpendicular lines. First of all, we have to think about what a parallel line is. Parallel lines are 2 lines that never intersect. And a perpendicular line is lines that intersect and create a right angle. So if I look at A, find the slope of A. A is down 2 to the right 3, so that's going to be negative 2/3. Slope of B, down 2 to the right 3 again. And the slope of C, if I start at 0, 0, I go up 3 to the right 2, so that's going to be 3/2. So what would we say? Parallel lines never intersect. So 2 lines that are parallel have slopes that are the same. Notice the slopes are negative 2/3 and negative 2/3. In C and B and C and A, those lines are perpendicular. If we look at them, they're opposites, meaning one is positive and one is negative, and they are flipped. And remember, flipped is a reciprocal. So we say they are opposite reciprocals. We take the opposite, so if it's positive, it becomes negative. If it's negative, it becomes positive, and then we flip it. It's a reciprocal. So the reciprocal of negative 2/3 is 3/2. If I have a number like 5, then the reciprocal of 5 would be 1/5. I would flip it.